All right, so what I want to kind of do today is just go over this lesson, making a video so that we had some, anyway, it doesn't matter. All right, so we're going to look at properties of limits in order to determine the limits of various sequences. So what we're going to talk about, first of all, are limits, and we're going to talk about end behavior, and we're going to talk about what happens as a sequence grows, or as a sequence continues on to the future. So when we're going to talk about limits, there are lots of limits that you can do in mathematics. You can do mathematics limits for end behavior. You can do it for as it approaches positive infinity and as it approaches negative infinity. You can do limits to discuss the behavior around asymptotes. We're not worried about any of that. We're worried about one specific type of end behavior, and that is as the limit approaches infinity. And the reason we're worried about that is because we're talking about this in terms of sequences. So remember, when we have a sequence has a domain of the counting numbers. So our domain is natural numbers. So if we have a sequence that says a sub n, let me rewrite that. A sub n is 5 plus 4n. Okay? So to find our sequence, to find the first term, we start with 1. So we're always starting with 1. So our sequence would be 1 times 4, which is 4, plus 5, which would give us 9. So our first term would be 9. Then we put in 2. So we'd have 8 plus 5, which would be 13. Then we put in 3, which would be 12, plus 5, which would be 17. Then we'd put in 4, and we'd have 16 plus 5, which would be 21. And what we notice is as we keep going, our numbers keep getting larger and larger. So when we're talking about this limit of sequences, what we're talking about here is as n approaches infinity. So for our sequence, what we're talking about is as the term number, so this is term 1, term 2, term 3, term 4, gets larger. Since this was given to us in explicit form, if I wanted to find the 100th term, I could. 4 times 100 plus 5 is 405. If I wanted to find the 1000th term, I could. 4 times 1,000, 4,000 plus 5. And what I can see is these numbers are just going to keep getting larger and larger and larger as my sequence increases. Now, if I had a geometric sequence, I could do the same thing. Let's say g sub n was 20, and I had 1/5 to the 1/5 to the n minus 1. So my first term would be 20, then 1/5 of that would be 4, then 1/5 of that would be 4/5, then 1/5 of that would be 4/25, and if I wanted to find the 100th term, I could do that because I would have 20 times 1/5 to the 99th. And it went to scientific notation if I wanted to find the 100th term. So I had 1.268 times 10 to the negative 68. And if I did that for the 1000th, it would even be smaller. So I can see that these numbers are getting closer and closer to 0. So what happens here is as my term numbers get bigger, this goes to 0, whereas this term goes to infinity because these keep getting larger. So the difference is this term is what we call, this sequence is called divergent because it doesn't go to a number, and this sequence is called convergent because as our terms get larger, the term itself gets closer to 0. So we're going to look at a couple of sequences besides the ones I just made up there. First sequence we're going to look at is negative n divided by 4. Now, before we talk about that, we're talking about something here called a limit. All right? And I don't know if you've seen limits before. So let me just show you what a limit looks like. If you're asked to calculate a limit, you'll see limit, and approaches infinity. For us, it's always going to be infinity because we're going to the positive infinity side. We want to know what happens to our sequence as the term numbers increase. And then in here, you'll have whatever the expression is. So we have n as it approaches infinity of negative n divided by 4. So what we're going to do is we're going to look at those terms. So we find the first term. We put in a 1. And over here, this is positive 1. This is negative 1. And we've got negative 1/4. So negative 1/4 would be about there. Then we plug in 2. And we get negative 1/2. Boom. Then we plug in 3. Negative 3/4. Boom. And so remember, what we're trying to decide is, does this sequence go to a specific number, or does it keep increasing or keep decreasing until it goes off the charts? We have negative 4 divided by 4, that's negative 1. Negative 5 divided by 4. Negative 6 divided by 4. Negative 7 divided by 4. And if you wanted to, remember when we find the limit, we're finding as n gets large. So if I wanted to find a sub 100, I could do negative 100 divided by 4, which would tell me it's negative 25. All right, maybe I want to do 1,000. So if I want to do a sub 1,000, that would be negative 1,000 divided by 4, which would be 250. That's negative. So you can see my numbers are just going to go off the charts, continually being negative. So what happens is this limit of this sequence does not converge. It does not exist. It's called divergent. Why? Because as the numbers get larger, this limit actually goes to negative infinity. So, and to do that, remember, you can always go to Desmos and put your sequence in. Right? And then hit this settings and view your table. And we only care about from 1 on, so we can just look at that part of the sequence. But if you want to check, all right, what happens for 10? What happens at 100? What happens at 1,000? What happens at 10,000? What happens at 100,000? And you want to see what your numbers are, you can see that those go on to infinity. They're just going to keep getting larger without bound. Okay? So that brings us back. So that's how we have no limit here. Now, the second sequence we're going to look at is a sub n equals 1 divided by n. So again, we're going to start by listing our sequences. Again, I have my graph here. So this is 1. This is negative 1 again. So I put in a 1. 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. So again, what we're asking here is when we consider this sequence, we're actually looking at the limit as n approaches infinity of 1 divided by n. So we want to know as n gets large, what happens to this term. So when I put in a 4, I have 1/4. If I put in a 5, I have 1/5. Put in a 6, I have 1/6. 7, I have 1/7. If I put in 100, a sub 100, I would have 1 divided by 100, or 0.01. If I did a sub 1,000, I would have 1 divided by 1,000, 0.001. And again, if you wanted to check it out on Desmos, you could do that. I'm just going to go here, and I'm going to change my equation to be 1 divided by x. And you can see these numbers get closer and closer to 0. So that confirms that I do have a limit. In this case, my limit is 0, so that means it converges to 0. So when you're asking yourself, or when the question's posed to you, consider the sequence. Does the sequence converge or diverge? you would say it converges. If it says state the limit, then you would say the limit is 0. Okay? So then there are several of these for you to try. So I would suggest that you pause the video and try to answer these questions, and then come back and check your answers. So again, I would suggest that you pause the video and then check your answers. So hopefully you did pause the video and you were able to come up with these answers. Now, if you're struggling with how we got these answers, stop by and see me. Text one of your friends in the class, see if they can help you. But definitely, if you're struggling, come see us. So the next question is, what about these limits like here? So we have 3n squared plus 5 times negative 1 to the n divided by n squared plus 6. And they gave us a graph here. So as you look at this graph, what do you notice is happening to the numbers? What are they approaching? Or are they approaching anything? To me, it looks like they're hitting like an asymptotic wall. It looks to me like they're stopping up here. It looks to me like that's pretty close to 3. Is this convergent? Yes. It converges to 3. As I look at my numbers, they get closer and closer to 3. Okay, so, and again, if you wanted to check it, you didn't see that there, you could always go to Desmos. And we have 3x squared. I wish I could remember this formula. Plus 5. Plus 5, parentheses, negative 1, parentheses. To the x divided by n squared plus 6. So x squared plus 6. And you can see the numbers there bouncing around, and you can also see that we have 2.877, 2.9987, 2.99987, 2.99999, and then finally it says 3 because it just can't differentiate any further than that. So that's a confirmation for us. Okay? Now, the next we have are properties of limits. So what these properties are for is if you happen to know the limit of something and you see it in a sequence, you can use that limit property to simplify. Okay, so I'll give you a few seconds there. Okay, so once you've got those jotted down, what I'd like to do is take a look at this particular piece of information. So if I were to tell you that the limit of a sub n is 4, the limit of b sub n is negative 2, and the limit of p sub n is 3, and then I ask you to find the limit as n approaches infinity of a sub n times p sub n. Well, our properties tell us that we can do that simply by writing the limit as n approaches infinity of a sub n times the limit as n approaches infinity of p sub n. Well, the limit of a sub n was 4. The limit of p sub n was 3. So my limit of the two sequences multiplied together would be 12. That's what these properties allow us to do. If I had the limit as n approaches infinity of 5b sub n. Okay, well, beautiful. So there's 5b sub n. Well, that means I have the limit as n approaches infinity of 5 times the limit as n approaches infinity of b sub n. Well, the limit of a constant is a constant, so that's 5. The limit of b sub n is negative 2. So I'd have 5 times negative 2, which would mean the limit of that product is negative 10. So that's how you could use those properties. Likewise, I could ask for the limit of p sub n divided by b sub n as n approaches infinity, which means I would divide those. The limit of p sub n is 3. The limit of b sub n is negative 2. So my answer would be negative 3/2 or negative 1.5. That's what those properties allow you to do. Okay? And then here's some more for if you want to do some practice on finding the limits. Again, I would suggest you pause the video and then come back and check your answers. And I hope this has been a helpful review for you, or if it's your first time, a good lesson.